green industry is an important part of U.S. agriculture, generating about $6.6 billion annually on average. The nursery crops obviously are an important part of the green industry. Nursery crops have condensed root systems, are grown in non-permeable containers, and are subject to high temperatures. As you can see, the non-permeable containers, this can limit the amount of oxygen available for root respiration, and root respiration is vital for root and plant health. Growing under the suboptimal rhizospheric oxygen levels can increase root rot susceptibility and decrease biomass. Atophora pneumoni incites the severity of root rot due to poor substrate aeration in woody nursery plants. A poorly aerated substrate will restrict root growth and plant development due to lack of adequate oxygen. These are just a couple examples of the problems with suboptimal rhizospheric oxygen levels. Simply put, my hypothesis was that increasing the dissolved oxygen level in irrigation water will increase the growth of nursery crops. I had two objectives for the research. My first objective was to evaluate a commercial oxygenation system to increase dissolved oxygen levels in irrigation water. And the second objective was to investigate the response of two woody species to dissolved oxygen levels in irrigation water and container substrate. The first treatment highlighted is the water dog treatment, DOG standing for dissolved oxygen generator. This technology has also been used on naval submarines to generate oxygen for the subsailors to breathe. Here's a schematic diagram of the water dog. As you can see, water flows into the water dog and then flows into two separate chambers, separating the water atoms into hydrogen and oxygen by a process called electrolytic hydrolysis. After it passes through these titanium plates, more oxygen is created by electricity. The oxygen and hydrogen atoms are then fused back together and then sent back out into the water line. And then my second treatment was, my control treatment was simply municipal supply. For my system development, I had designed and built an irrigation plot, which included setting up 4 lines per treatment and dividing them into 8 blocks. For verifying water treatments, 4 blocks were randomly selected and samples were tested during the month of July, while 5 blocks were randomly selected, sampled, and tested during the month of September. All 8 blocks were tested in the were sampled in the month of October, and then this is an example of the month of July. Okay, for my first, to evaluate the dissolved oxygen level, we took measurements in milligrams per liter. As you can see, the water dog treatment on average was 13.7 and the control 9.6, and this signified a significant difference in dissolved oxygen levels in the water treatment. The plants selected for my experiment were Cornus Florida, or dogwood, and Forsythia intermediate. Dogwood was chosen because it's a very important crop to Tennessee and increasingly grown in containers, and growers are finding it more difficult to grow in containers rather than in the field. We hypothesized that it is sensitive to low dissolved oxygen levels, and we wanted to use Forsythia as a comparison because of its perceived low oxygen requirements. The substrates used were a heavy substrate, chosen because of its low aeration and tendency to hold water, and an 85 pine bark, 15 peat substrate, which is chosen because of its high aeration and tendency to drain water. Using Microsoft Visio, I created a schematic diagram of my irrigation plot, each color corresponding to a specific treatment, yellow being the control and blue being the water dog, each shape representing a different substrate, the square representing my pine bark substrate, circle representing my heavy substrate, and each plant picture representing its species of plant, the light colored plant being the dogwood, and the dark colored plant being the forsythia. And then here's a picture of my completed irrigation line. preliminary short-term experiments using this system, there was no effect of elevated dissolved oxygen on the cornice plant height. However, using the same system for the forsythia, there was also no effect on the elevated dissolved oxygen on forsythia plant height. However, there was a significant difference in the height based on the type of substrate used according to the S statistics. There was also no effect of elevated dissolved oxygen on dry weight. There was greater root dry weight for cornice growing in peat there was greater root dry weight for cornice growing in the peat and pine bark substrate. Using the same system, there was no effects of elevated dissolved oxygen on dry weight. However, there was greater biomass in forsythia growing in the peat and pine bark substrate. So in conclusion, was successfully able to consistently elevate dissolved oxygen levels with the water dog. There was really no difference in plant growth due to the dissolved oxygen level. Dry weight increased in the higher quality substrate, and further research is needed on the effects on growth and disease susceptibility. This is significant to the industry because we believe that dissolved oxygen levels increasing dissolved oxygen levels have potential benefits of increased biomass, fuller and healthier root system, and increased susceptibility to disease. I would like to thank you. Thank you.
Any questions for him?
What do you think would have happened? Because your municipal DO is rather high. I mean, a 9, that's pretty high. What do you think would have happened, or do you think you would have had different results had your control DO actually been lower, like if you were drawing from a pond or a situation like that?
Well, we actually had that problem happen in the beginning of the summer when we tested both DO levels were elevated, but as the season progressed, the levels actually changed, and we don't know if that was due to how municipal water was treated or whatnot, but we actually found that the ratio or difference between the water dog and the control averaged around 3 or 4 milligrams per liter greater each time, regardless of what testing we did. We did have to make sure that the dissolved oxygen meter was, calibrated correctly, and we had to make sure we had to take out any variables like how far we put in the meter and things like that. Sure.
Did you water all the plants with the same volume of water?
Yes. Each day, what I tried to do, in the morning, I would run and bleed off the line for about 5 minutes to make sure impurities and heat and everything would be taken out, and then I would water each plant was set up. Each plant had its own emitter. We actually kind of reversed them where we put the emitters actually in the black polyethylene tube.